In this video, I'll show you what a typical session when I'm doing development or using the development tools looks like. So I'll start by opening a few applications. As I open those applications, I'll talk you through them. So I'm gonna do my development for the MSP M0. This is the MSP M0 G3507, which is this processor that I'm going to be using. This one has we've discussed about this in class. This is the board that you have in 302, which you'll continue to use in 319K. So we're going to use this for our development. So first thing I'm going to do is I'm going to open my my environment tools that I need. So I'll open PowerShell because PowerShell is what I'm going to be using to communicate with that board. So I have a couple of, let me clear this one. So I have an old one that has already been opened. This is the PowerShell is what I'm going to be using for doing the PowerShell is where I'm going to interface or connect to the board. This is the board. This is the red board that I'm looking at, the MSPM0, and I'm going to talk to that using the PowerShell. Specifically, I'm going to run an application here called OpenOCD. We'll see how to run it. I'll try to show you a way so that you don't have to keep typing a lot of things. We'll have them in some place so we can cut and paste for the most part. So the next thing we're going to do is we're going to open our shell. Ideally, I'd like to, that's Ubuntu is my shell that I'm going to be using, my terminal, and I'm going to open a couple of them. So the way I like to work with this is I'm going to create a few of these. So let me do that here. So I've launched one. I'm going to launch a few more because I'll show you exactly what an development session might look like. I'm going to open this guy and I'm going to run it on this side. So I have two of these. In fact, I'll open a third one and I'll show you why I'm opening so many in just a second. For now, let's say this is our environment. So I have a project that I'm going to be working on. When I'm in this is my WSL Linux. So if you did the installation properly, you should have two folders. One is called MSPM0. I'm going to go in, change directory into it. MSPM0 is the directory. So if I'm here, you will see a bunch of projects. These are the projects that I gave you. Now since I'm working on the real board, this is the place I'm going to be working off of. So let's open a project. I'm actually going to open a project called IO Basics. So I've changed directory into that. CD is for change directory. And now I'm in there and I'm going to do the same thing. For now, I'm just going to hold on to that thought. And I'll actually let's go to this part and so that I can see the project I'm working on in one directory here. Let me do that. I'm going to CD again into MSPM0 here as well. I'm going to go into my IO Basics. And I can edit my files here. If I look at what typical project is, it has a make file, a readme, a couple of folders. One of the folders that's of interest to us is this folder called source. This is where our assembly file is sitting. So I'm gonna run this program by first building it. So the way we build it, it doesn't matter which terminal you use. I'm gonna build it here. I'm gonna say make. And if you don't know what to do, just read this readme here. To read a file in Linux, you do cat and you can hit a tab and it'll complete it. So I can read that file. It says this is a bare bones assembly project. It's giving you a little description about it. It tells you that it flashes a white LED, which is I'll tell you what the white LED is in just a second, or a red LED, depending upon whether switch S1 or S2 is pressed and held. So it says if you want to build this, first run make, which is what it says here to build, run make. So I'm going to make. So I had previously made it, so it's going to just do whatever needs to be done. So if I want to start with a clean make, I say make clean. I type make clean. It removes all the things that was previously created. And if I say make, it'll create a fresh copy. So what I'm really doing in this step is I am running a bunch of utilities. I'm running an assembler to assemble the main program. This is the main program I'm assembling. I'm going to run the assembler to also assemble two other files, which are called the startup file, which is the Cortex M0 file, and an operating system which I am providing, which is called YOS. So these are all being assembled, and eventually I'm going to tie them all together using something called a linker. So the linker ties them all together and creates what is called an object file. And the object file is going to be placed in this folder called obj, and it's going to be named iobasics.elf. If you're curious to see what exactly is in the make file, you can look at the make file. It should be pretty straightforward to understand. It's just telling me here, it's listing all the programs I'm going to be using. It's telling me what my final elf, the object file, is going to be named. It's going to be called iobasics.elf. So I gave it a name, my program name, and these are commands that are all telling the system to, if I run make, what does this program depend on, and how to build all the dependencies. That's really at the heart of what make is. And when I type in clean, it says I'm going to remove all the things that have previously been done so that you can start with a fresh copy, fresh build. So that's basically what the make file is doing. So now now that I'm going to go back and look at my readme again. It says once you make, you can look at you can run the utility called openocd, this particular command. If you run it in the PowerShell, then it's going to connect to the board, and then we run this utility called arm debug gdb to debug the program. So let's do that. I'm going to first run this code. Right now I'm only going to run, and then I'm going to show you the code itself that is running. So I'm going to copy this, just Control C, and I'm going to go here, which is where I have my shell, which is the shell is here, and I'm going to paste it. So if I paste and run it, it'll connect. And right now it's going to connect to my board, and it's saying that it's listening for commands GDB, which is a debugger, connections, commands on port 333. Now I've provided a bunch of shortcuts, so you don't have to hide some details for you. Eventually I'd like you to learn all these details, but for now, in the interest of making sure that you're understanding everything, I'm gonna provide some shortcuts. So now it says to run it, I should do this. So I'm going to copy this guy and I'm going to run it here. So now if I do this, it's going to launch my debugger and it's going to run this program. So while I'm running it, I also want to see what code I'm really running. So I'm going to use this editor called Nano. Nano is an editor which should be very simple to use. It's like any other editor. I put a bunch of shortcuts so that all the things that you're familiar with, how to cut, how to paste, all those are intuitive and straightforward, like you are familiar with. So I'm gonna open the file called source under source. There's a file called main.s. I'm gonna open that file. So I'm gonna open it here. It has a nice way of showing you. It's colored, so you can see your code where various things are, your pseudo ops are all colored differently compared to your program. Instructions are all white, comments are all green. So that it's very simple to look at and not and it shows that whatever you're typing, it's understanding. So that's the basic idea. This is called syntax coloring. So let's look at what we're going to run in just a second, but first let's run it. So I'm going to run this code and I'll walk you through what it's really doing. So once I launch the GDB program, which is a debugger, to connect to the OpenOCD program, I'm going to run a command that I provided called debug. this debug will connect to the OpenOCD. So I'm going to run that. So now it's going to take a little while, it'll launch it, and I have currently, I'm looking at the code. If you see the source code here matches the code I'm looking at here. So it's saying that it's currently on line which says BL Launchpad in it. I'm not going to go into the details of these instructions, but for now, just remember that all the code we write, eventually when it runs, the label, the routine or the function where every program starts is called main. So the main is where I'm going to start. So that's why it's on that line. Now I can single step through it, or I can do things like that. So I'm going to show you a few things I can do. So for now, let's go back here and let's run this program. So I'm going to do instruction. I'll show you some of the instructions. N is for next and S is for stepping. So I'm not going to go into the routine called launchpad init. So I'm going to say NI. So it's going to get past that. Oops, I think I did it's actually doing a next on main. So let's come out of here. And right now it's going to be on this line. Actually, let me do this. So it's looking for, it's on line 18. I am gonna single step. So let me show you the essence of what this loop is doing. It is going to call a function called getS1, and getS1 is going to give me a cop. So if I look at my board, so this is my board, and there are two switches on it. There's a switch on this side and there's a switch on this side. So there are two switches, and I'm basically looking at which switch has been pressed, whether switch 1 is pressed, switch 2 is pressed. There are lights on this. There's a light here which you already see is red. Next to it is a light which is white, and that white light I'm going to manipulate those two lights. So let's get back here. So if you look at the flow of the program, this is a loop called loopy. It gets the state of switch 1. If the switch 1 is not pressed, which means I'm comparing the result it gave me, R0 gives me the result. If R0 is 0, it tells me that switch is not pressed. So I'm going to compare it against BEQ, and if it is not equal to 0, if it's equal to 0, actually I'm going to go to switch 2, because switch 1 is what we call as a negative logic, and we'll learn that later. For now, just bear with me. S1 will return either a 0 or 1. If it returns a 0, then it means that switch is not pressed. If it returns a 1, then the switch is pressed. So if the switch is pressed, I'm gonna go and execute this piece of code. If the switch is not pressed, and I'm gonna go here and check if switch 2 is pressed. Again, I'm gonna do the same idea here, which is I'm gonna check and see, and if switch 2 is pressed, I'm gonna execute some other code. So let's just focus on this piece of code here. If switch 1 is pressed, then I'm going to come to this line. And if I'm on this line, I'm going to do this piece of code. What exactly am I doing here? Let's just grab this piece of code and see what exactly is happening here. So this piece of code, in a sense, is saying that I will call a function called BL white on, and then I'll wait, and then I'm going to call a delay, but this delay takes an input in register R0. So delay takes an input in register R0, which tells you how long it's going to delay for. So, and this number 16 million is going to make it delay for 1 second. And so I'll make it delay for 1 second, and then I'm going to call white off, which will turn off the white LED, and then I'm going to delay for 1 more second, and then I'm going to go loop back. So there's going to be a B loopy here, so which will take me back to the beginning, and again check if the switch has been pressed. So that's the idea. So what I'm going to do is I'm going to put a breakpoint in. So I'm going to put a breakpoint in this function called white on, so we can see what exactly how exactly I turn the light on, white light on. So I set the breakpoint and I can say continue now. If I say continue, it's going to go and it's going to stop in the function called white on. And the reason why it's not doing it right now is because it only goes to white on if the switch has been pressed. So I'm going to press this button, which is the switch. I'm going to show you which switch I'm going to press by showing you here. Here is the switch. This is the switch 1. So I'm going to press that. The act of pressing that switch should take me to the function called white on. So I'm in white on right now, and I'm going to step one at a time. So let's take a look at exactly what white on is doing. So let's grab this piece of code here and understand what it's doing. So this is white on. So what does white on really do? So we have memory mapped registers. Remember how IO works. Memory mapped registers. For our machine, on our system, all the pins on our system are on a port. So a port A, so this is actually port B. Port B has 31 pins on it, 31 through 0. Now, each of these pins corresponds to something. Turns out that pin 26, bit 26, pin 27, and pin 22, they correspond to, as the code here says, let's see where the code is. As the code that we saw earlier, it says that our switches are on, our LEDs are on PB 26, 27, and 22. Let me bring that up again. So that's our code. And let's go down to white on, and there's a comment on white on that tells us that our pins are, so that's my white on, but let's take a look at where are the names of various LEDs are. Actually, it's in my readme, so let me go to my readme here. CD MSP M0 IO basics, more on readme. So it says here that I'm going to copy this from here. It says flashes the LEDs, and here are the various things that we have. It says we have PB26 is a red LED. It controls a red LED. PB27 is the blue LED, and PB22 is the green LED. Actually, no, PB26 is red, PB27 is green. This is my green, and PB22 is the blue. So those three LEDs are packed together in one spot, and I'm going to turn, if I were to there's a data register. This data register is called GPIO GPIO B underscore D out underscore D out 31 underscore 0. So this, if I were to write a 1 here and a 1 here and a 1 here, then the act of writing 111 is going to produce a white light, because I'm turning on all three of them. For example, if I were to only do a 1 here, so let's do another one. If I were to write a 1 here, a 0 here, and a 0 here, then I'll get a pure green light. Again, if I write a 0 here, a 1 here, and a 0 here, I'll get a red light. And if I write a 0, and a 1 here, then I'll get a blue light. Right? And you can turn more than one on. Some combination of them will get you different things. So this particular code I'm looking at here, what this code is doing is, it's actually, there's another register called GPIOB underscore D out set 31 underscore 0. So the act of writing to this register, this is a register where it is, if I write something to this register, if I write, for example, if I write this is 27, 26, and let's say there's a 22 here. So the act of writing a 1 here and 1 here, which will go and modify those registers. So whatever I write to this will change that, because by writing set, set means that I'm asking it to set those pins. There is a similar register that we will use that will allow us to do clear, which is a GPIO. There's another one called GPIO B out CLR 31 underscore 0. If I, in that register, if I do the same thing there, which is on bit 27, I write a 1. If I, on this one, 26, I write a 0, 1. And on 22, if I write as 1, then the act of doing that will make all of those in that register become zeros. In this register, they become zeros because I'm asking it to be cleared. So this is these are some registers, some IO registers or memory mapped registers that allow us to control this particular, those pins. So that's the logic behind it. So now let's go and see whether how this works. So I'm going to I put a breakpoint on this line, and I'm going to single step. So I'm going to do one more NI. So I'm going to do an NI here. So it's going to step over, and now I'm about to do a NI. And if you notice, this mask I'm using here, is exactly what I want, which is bit, it's 0, which is 0000 in hex. Then I have a 1100, which happens to be bits 27 and 26. And then I have a 010, which is 4, which brings us to bit 22. So I created this mask, and I'm going to store this mask. The store operation is going to store it to that location. So this one got R1 gets the address. R0, this one says R0 gets the mask I want to write, and this third line is going to store the mask to the address. And by doing that, if I were to execute that third line, and let's do this right now, it's on line 109. If you notice, it's highlighted here with a different color. So if I do an NI now, then I should be able to see the color change. So here's, let's go back and look at my LED. This is my board right now, and I'm about to say NI. If I say NI, it executed that line, and right now the LED is white in color. You'll see that the LED is turned white in color. Now, if I put a breakpoint, let's put another breakpoint and put it in white off. If I put a breakpoint on white off and I say continue now, it's going to break on white off, and right now my LED is still on, and so I'm going to step one at a time. I say NI, and if I ran an instruction, if I ran a command, I don't have to run it again and again. If just the act of enter will rerun it. So now if I were to run this third one, and you're noticing on the side here the video is showing you the LED. If I were to run the store, that will turn off the LED, which is exactly what I want, because I wrote it to the out clear register this time, so I turned it off. So let's do one simple thing here. Now I can add breakpoints, I can delete breakpoints. If I just say B, it'll tell me the breakpoint that is currently set. So I can say I want to delete this breakpoint. I can say D, which will delete all breakpoints in my code. Now if I delete all the breakpoints and say continue, then it's going to start continue to run. So it's continuing to run, and now I can show you what the code should do. So if I press this button, which is the button which we talked about, and hold it, if I were to press this button and hold it, the white light is blinking. there's a similar routine for this other button on this side. If I were to press that, which is called switch 2, then the red light is going to blink, and it's blinking at 1 second, like 1 second on and 1 second off, right? So that's our code, and if I want to stop the code, I can just say Control C and it'll pause the code. And right now within my code, it's sitting in this get s2, and that's where I happen to have stopped the program. Now this is how we debug our code. And so when you're done, you can just say Control D and you can come out. Now I'm going to run another example in a second video in which I'll show you how we can debug on a virtual board, and there I'll show you a few more things about how we can manipulate our IO. But first, let me just go through and show you a couple of things you could do with the code. I want you to think about how this code can be modified so that I can make this LED blink a different color. So let's just play with that. So that we can just say, what if I want the LED to be such that I will not, rather than white light being on, I'm just going to turn the green and red light. So I'll make these two guys be 1s, but I'll make this one be a 0 and see what color I get. Or actually, let's do this. Let's just do so that it's interesting. Let's do green and blue. Let's turn on green and blue are on, and red is off. So at least it'll show us how the code itself works, what the general idea when you modify your code, what should you be doing. So I'm gonna just modify this white on, which is the code that I have down here. I'm gonna modify this code so that I can get the color I want. So in other words, now let me redo this. I have my register, and I'll also do it slightly differently, and I'll show you what I mean by that. There's 27, 26, and 22. This is my blue, this is my green, and this is my red. And that's what we remember looking at when we talked about the code. Here's again the description that tells us what the various pins are. It says red is 26, sorry, red is 26 and green is, it's the other way. So red and green. So what I want to do is turn the green on and the blue on. So my mask I'm going to use is going to be a 0x, because this is a 1 0, so it's going to be 0x 08 4 0 0 0 0 0. So that's my first nibble, and that's my first and second part of my first 16 digits and second 16 digits. So let's do that. I'm going to go into my code now, and I'm going to change this to an 8, and I want to turn it off. Here I'm going to make that an 8. So let's do that. I'm going to save it. I do Control S to save, and once it's saved, I can go here and I can make it again. So I'm going to make it again. So I did a make again, and now I can rerun my code. So I'm going to run my debugger. In the meanwhile, the OpenOCD program is still connected to it, and it's saying I'm still connected. If you disconnect, I'll still stay connected. You just tell me when you're ready to talk to me again. So previously detached from the target, now I'm gonna connect myself again. So I'm gonna run it again. So let's do that, and I'm gonna say debug again, and so now I'm connected to it, and I have a fresh copy of the program I'm running. Now again, let's break on white on, though I didn't really, it's not going to be white light anymore, but I'm going to continue, and so it should break at that point. So it'll only break when I press a button. So let's do that. Let's bring this guy back, and I will actually, let's do this. I'm going to just use that, and let's put these guys back so I can see what's happening. And so this is my switch I'm gonna press, and I'm gonna press the switch, and the act of pressing the switch should break me and cause the breakpoint to run. So I pressed it, I got the breakpoint, and now I'm gonna single step. I can do an SI or an NI because there's no subroutine here. Step or next is exactly the same. I say an SI, and then I say SI again, and now when I say this, it should turn a color, and the color I got happens to be a yellow color because it seems like that's what the combination of those two is going to do. So the combination of those two colors that I just did, which is the green, which is green on, and G and B together is giving me this color, which I think is a slight aqua color. I don't know, it's an aqua color, which you guys can't see very well, but it, to me, when I'm looking at it in my with my bare eyes, it shows like it is aqua color, which is easier to see. If you kind of hide a little bit of the brightness, you can see that it's actually an aqua color right there. All right. So we kind of know the process by which we can edit our file, change it, and then rebuild our program, and then run it again, and put breakpoints and watch things. I'll run another program where I'll show you a few more things that you can do. Now, the editor itself is pretty straightforward. As I said, you can find things in here. If you're searching for something, you can say Control F, and you can search for something like, for example, if I want to search for white off, then it'll take me there, and that's where white off is. And so you can search things, you can replace things, you can undo things. Let's say I did something wrong here, then I can say Control Z, which will undo it. If I want to cut a line or cut some stuff, I can copy this, or I can cut it. If I want to cut it, I say Control C. If I want to and I can paste it somewhere if I wanted. Let's say I wanted to paste it here, then I say Control U for paste. And if I don't want it, I can say Control Z again. This is Control U for paste here, but though it says Control V for paste down here, Control U is to paste in application. If I want to paste something from outside, then I use Control V. For example, if I had something somewhere, let's say I have this word XDS, if I copy this from here, and if I want to paste it in my editor, then I can paste it wherever I want to. If I say Control V, it'll paste what came outside the app. So outside the app is Control V, inside the app is Control U. So most of it is pretty straightforward otherwise. There's a way to replace things. The Control H will replace, search and replace things that you want. It has a bunch of other things which you will explore as you go along. My usual process is every time I make a change, I will save it by using Control S. It says wrote lines, and once I'm done, I'm gonna quit by saying Control Q. So this is my usual process. In the next video, I'll show you how we can do some interesting things with the debugger.